Yeah, first, thanks to Anna Thorn, like organizing such a wonderful event. I'm going to talk about Manta, which is a plug and play privacy for Polkadot. So first, tell you guys a little bit about me. So I'm a co-founder of Manta Network, also assistant professor at UCSB. So a little bit history for me into the blockchain space. I actually ran the first blockchain seminar at University of Washington while I was still a graduate student there. And then I become a research scientist at Algorand. And for my own research, I'm very interested in applied crypto, privacy-preserving ML, and blockchain systems. So since in the last few years, I've been in Seattle and then Boston and then Santa Barbara. Please don't ask me which one is my favorite city. So I don't think I need to motivate you guys about the cryptocurrency. It's really eating the world, and I think for the good. I think common problems of the cryptocurrency is that we probably all know that pseudo-anonymity doesn't mean privacy, right? It's actually pretty against privacy in the sense that we have a public ledger and like everyone's transaction record is on chain, and it probably forever, right? If you think about that, that's pretty scary. And don't take my word, actually takes Mr. or Mrs. Satoshi Nakamoto's word for himself, right? He probably argues that we need a new address for each transactions. So actually what Satoshi Nakamoto didn't envision is that's probably not enough. So for example, even if you have a new address each time, right? So the machine learning techniques are becoming extremely powerful these days. So they can do the link analysis, basically tracking the lineage of the transaction record. And even if you get a new address, so like all the privacy mining companies still can probably get you, right? So so to motivate you a little bit more, so we actually did a privacy survey. Right, so a lot of people argue that, hey, like privacy is that thing that everyone is talking about, nobody really cares. But at least from our survey results, right, we survey a wide range of users from with a different kind of like experience and different years into crypto, right? I think a majority of users that actually concern the linkage between their identity and their addresses. And the next result is even more interesting, which is like 90% of the users have inspect others' wallet addresses. And there are like more than like 70% of users have avoid or hesitate to make a transaction because of privacy. So I think the problem here is not really people don't want privacy. It's like we don't have a easy to use privacy for the users. And I don't think the tech is there. Right, so people usually talk about the privacy kind of like a utility trade-offs. I think there are some inherent trade-offs, but I do think we can push the Pareto kind of like a Pareto frontier, in the sense that we can make the privacy techniques more friendly to the users. So that's brought you to Manta's mission. So we are trying to be the plug and play privacy layer for Polkadot. So Manta is going through many three phases, basically. So the first Manta 1.0 we call the Decentralized Anonymous Payment System, right? So this is actually the fundamental of Manta stack. So the first thing we are going to build and have already been partially built is a decentralized anonymous payment system, which is essentially a privacy layer for the fungible token transfer. Right, so the process that you can use Manta is that you can take your own like a public crypto token, and then through the mint process, and mint in Manta, and we'll give you a private token, and you can use this private token to transfer to any like a shielded address you want, and also if you want to get back to your public crypto tokens, you can go through the reclaim as well. So the Manta protocol itself is pretty similar to Zcash, with some improvements. For example, we're using like sharded Merkle trees. There are like a few technicalities I won't get into super deep here. But the key differentiator here is that we want to be a plug and play layer for all the Polkadot and Parachain assets. in the sense that we're going to support all the parity and relation assets, including dots like AUSD from Akala, like USDT from Tether and RenBTC, and all the coins that probably a lot of projects participating here you are going to issue, right? So that's really the Manta 1.0, right? So just dive into a little bit deeper into tech. So in a very high level point of view, I will tell you how does a private transfer work, right? So think of the public blockchain as a public ledger, right? In a public transfer, you basically send a transaction, for example, Alex and Bob 50 coins, and then like every single validator is actually re-executing the transactions. And in Manta, right, it's very similar, except the both ledger state and the transactions is encrypted. So in the sense that the transaction are actually not just plain text, but encoded by using the zero-knowledge proof. Here is Pi transfer. Basically, this Pi transfer is proving that the ledger state transformation from the L1 to L2 is valid. And then all the validators is running a Zk Snark, and all the validators is validating this, like the validity of this zero-knowledge proof. Right, this is a very high-level point of view. So, so I will give you a little bit, like very slight overview of Zk Snark. Right, Zk Snark is such a wonderful thing that basically can prove you a fact about computation without leaking any information. So, for example, so there is Alex and Bob wants to prove to Alex, for example, I love you, and then essentially, and without leaking any information. Right, basically you go through this key generation and this like a proof and validation, right? So this is again, this is very high level. We probably don't have much time. So for the Manta 1.0, we have already built a prototype. You can see there the still and the bell and whistles, but basically we built a prototype on Substrate, and it's already working, and we're still working on the user interface and the front end, right? So, so for the Manta ZKP concrete performance, right, we require trusted setup, but we don't think that's a big issue here. And our prover efficiency is about 10 seconds, and our verifier efficiency about like a 10 millisecond. And I mean, thanks for the wonderful things that the Polkadot ecosystem have built a very efficient awesome runtime. So that's Manta 1.0, basically the plug and play layer for the fungible token transfer for all Polkadot ecosystems. And then I will going to talk about a little bit about Manta 2.0. So Manta 2.0 is going to be a decentralized anonymous exchange, right? So let me remind you, the Manta 1.0 is basically you take your token and mint to a private token and do the transfer and reclaim. And the Manta 2.0 is actually very similar, right? You can take your favorite token and mint to a private version of the token, and then you can do exchange to the private token, another kind of private token on Manta. And then perhaps if you want to claim back, or you can use a new private token to do the transfer, right? So again, the working host here is still Zk Snark. And for the exchange mechanisms, we're actually using the automated market maker, right? If you are not super familiar with the automated market maker, and essentially it's you can think of, instead of trading against some users, you are actually trading against a pool, right? And there is a curve, this is called x times y equals to k. And essentially the pool has two assets, and every point of time this pool maintains this invariant along this curve, right? So let's say if you want to trade something, right? So basically the position will move along the curve, right? So I won't dive super into details, but I think why the AMM is great for several reasons, right? First is it actually brought you a little bit of front-running resistance. And second, and actually most importantly, right, Ethereum it will translate to gas efficiency, which means the AMM is extremely simple to construct. And in Polkadot, and also in like a kind of like a zero-knowledge proof term, it will actually transfer into like a zero-knowledge proof efficiency, in the sense that the circuit will be way more simpler compared for example, you build like a order book-based AMM, Right? Also, it will have like a few like a market efficiency. And please, so there is a kind of like a Stanford literature about the detailed analysis. Right? Again, in a very high level point of view, the difference of the DEX scheme here is that instead of so we basically adding the AMM invariant to the zero knowledge proof, right? So then I'll also give you a very preview of the Manta 3.0, which is a privacy preserving smart contract platform. So take advantage of Amazon, right? So basically, Amazon first build a product, then become a platform, and we want to go in the same way. So from the architecture point of view, so once we build the Manta like a private payment and DEC, it will become kind of like library layer, and it will support like a smart contract, for example, ZK rollup, banking, non synthetic asset, and NFT, and so on. Right. So a little bit. I'm probably running out of time.
Yeah, actually, Shumo, I was going to sort of jump in.
Yeah.
Just one thing I want to mention is that at the end, when we do the breakout sessions, actually, if people want to have a bit more conversation about this, we can actually do that at that point. And just so you know, there's actually a question in the chat that maybe after your talk, you can answer in that chat as well. Right. But shall I just say thank you then? Thank you so much for the talk. Okay, great.